Today on How It's Made. Game calls. Mayonnaise. Traditional razor blades. And butterfly safety razors. The invention of mechanized game calls in the middle of the 19th century allowed hunters to mimic the sounds of their prey. Before these devices came along, hunters whistled and made noises with their hands to lure birds or animals into shooting range, and their efforts weren't always on the mark. Whether it's a mating call or just a sociable hey there, a game call is about speaking the language. Of course, it all translates into big trouble for birds and animals who respond. There are dozens of different game calls, from duck to goose to elk. Each game call is a precisely crafted instrument. To make one, they don't have to look far for raw material. A bamboo crop flourishes in the backyard of the Louisiana factory. Bamboo is one of the fastest growing plants on the planet, so there's always a ready supply. The stem is hollow, which makes it ideal for the game call's larger barrel. After the bamboo cane has been dried for 6 to 8 weeks, they cut it to length, about 3 inches. But bamboo isn't the only wood they use for making call barrels. Others are constructed from walnut, cherry, or exotic woods. They're harder and a bit more rugged, but of course, they're also solid. A boring machine hollows out these solid walnut blanks. They load them 6 at a time into the machine's slots, and then lower a holding bar to secure them for drilling. A carriage moves the drill bits forward, and they hit the walnut blanks dead center. A worker locks a hollow barrel in a lathe. As it spins, he manipulates a blade to carve a slightly concave profile. This will make it easier to grip. He also cuts designs into the wood, which identify this instrument as a certain duck call. Each call has its own distinguishing design. As the duck call barrel continues to spin, he sands away any burrs or splinters. What was a simple wooden tube now has flowing lines and a defining design. Next, they spin a stone on each end of the barrel, creating a burn that blackens and smooths the rims. The game call barrels then funnel into the clutch of prongs on a revolving wheel. As the wheel turns, the barrels brush against a series of sanding belts, each one with a finer grit than the last. This final sanding makes the barrels super smooth. With a set of pincers, he dips the barrels in a solution to seal the wood inside and out. The sealant will protect the wooden barrel from rain, humidity, and the user's saliva. After dipping, he leaves the parts in the sun for several hours to bake on the sealant. Meanwhile, they machine a smaller barrel, which will hold the noise-making parts. Using a reaming tool, the worker tapers the opening of the larger barrel, and the 2 barrels now fit snugly together. A worker buffs the barrel with steel wool as it spins on a mandrel. The buffing gives the wood a silky texture and prepares it for a final sealant. Production now turns to the noise-making insert. A worker pounds a die into a strip of rigid plastic to punch out the reeds. It's this part that vibrates against the tone board to produce sound. The reed shape varies depending on the kind of call being made. He aligns the reed with the wooden tone board and then inserts them part of the way into the barrel of the game call. He sands a little wooden wedge that will hold everything in place. He pushes it into the space between the barrel and the reed and tone board. Then, using a metal file, he forces the wedge even further into the opening to ensure the parts won't budge. He slides the larger barrel over the protruding reed and tone board. After some tuning, the game call is ready. In a way, Hunting calls are like musical instruments. It takes practice and know-how to use one successfully. But once mastered, this instrument could attract flocks of admirers. After all, every game call has a target audience. According to one theory, mayonnaise originated in the town of Mahón in Spain, where it was known as salsa mayonnaise. Mayonnaise makes sandwiches zestier, turns canned tuna into tuna salad, hard-boiled eggs into egg salad, and is a creamy dip for French fries Belgian style. Mayonnaise recipes vary, but all have eggs and oil as the main ingredients. The eggs can be all yolks, all whites, or a combination of both. At this mayonnaise factory, the raw eggs arrive in liquid form by tanker truck. They've been pasteurized to kill off salmonella and other common bacteria. The egg supplier has also cleaned and sealed the tank valve, an additional food safety precaution. A worker clamps a sanitary evacuation hose to the tank, then with a few blows of a mallet, releases the valve. A pump draws the eggs through the hose into a refrigerated receiving tank. The second main ingredient, soybean oil, arrives by a railway tanker car. Like all bulk ingredient deliveries, for food safety, the tank is sealed at the supplier to ensure it isn't opened prior to arrival here. A pumping system transfers the oil to a large holding tank. Meanwhile, factory workers weigh out the ingredients that make up this company's secret blend of spices. Next, they mix this spice blend with white vinegar, cider vinegar, and salt. Then they add liquid natural flavors. They pour this mixture into a large tank of room temperature water, producing what they call a slurry. The raw eggs, meanwhile, have been transferred into a large refrigerated holding tank. So now there are 3 holding tanks at the ready: a slurry tank, an egg tank, and an oil tank. A computerized proportioning system extracts the required amount from each tank and sends it to a mixing vessel. A couple of minutes of mixing at high agitation merges the eggs, oil, and slurry into tangy, creamy mayonnaise. The factory draws samples periodically and sends them to its quality control department for analysis. The lab technicians there evaluate several criteria, such as color, consistency, and of course, flavor. In this test, for example, they mixed the mayo with phenolphthalein, a pH level indicator, and deionized water to check the acidity level. Once the mayonnaise passes quality control inspection, this rotary filler dispenses it into recyclable polyethylene jars. It fills each jar in just a quarter second. The next machine twists on a plastic cap. Inside the cap is a foil seal. This machine uses targeted induction heat to fuse the seal to the rim of the jar without heating the mayonnaise in the process. The seal preserves freshness and indicates the jar wasn't tampered with after leaving the factory. The labeling machine glues on one end of the label, spins the jar to wrap the label around, then glues down the other end. The Quality Control Lab also performs some post-production spot checks. In this test, technicians use a machine called a viscometer to measure the product's consistency. The factory also packages its mayo into single-serving pouches. They're made of polyethylene film on one side, foil printed with the product label on the other. This multitasking machine forms rows of pouches, inserts about 4 ounces of mayonnaise per pouch, then seals and separates the pouches. These pouches are shipped to ready-made sandwich vendors and fast food restaurants, whose customers need mayo on the go. Cavemen sharpened pieces of flint and used them to shave their facial hair. Modern man can simply go purchase a pack of razor blades for his shaver. While several styles of shavers and blades exist, many men believe the traditional type of razor blade gives the closest shave of them all. They're paper thin, yet sharp enough and strong enough to cut through the coarsest beard. Razor blades are made from a stainless steel strip that's a mere 4/1000ths of an inch thick. The strip first enters a punching machine that stamps out the overall blade shape. These dull-edged blades to be are called blanks. At this stage of the process, the stainless steel is very soft, as pliable as paper, so they now harden and strengthen it through a 4-step heat treatment process. Step 1. They heat the blanks in a furnace to just over 2000 degrees Fahrenheit for about 30 seconds. Step 2. They briefly submerge them in cold water. This is called quenching. Step 3. They chill them for about 20 seconds in a deep cooling chamber at a temperature of -58 Fahrenheit. All this progressively restructures the molecules, hardening the metal. However, the metal becomes brittle, necessitating reheating the blanks for 20 seconds. The now hard blanks then move through a printer, which applies the razor blade brand name. Gas flames instantly dry the wet ink. Now it's time for the blanks to become blades. They enter a grinding and polishing machine. Within it are 3 grinding stations which first sharpen the contour, then produce 2 super sharp cutting edges. The blades then pass through a polishing station that removes burrs left by the grinding. Until now, the blades have been connected to each other. As they exit this machine, a knife separates them. The factory's quality control lab pulls samples from the production line and checks, among other criteria, the quality of the grinding and geometrics of the cutting edges. Then, every single blade the factory produces is examined for cutting-edge defects. Technicians assemble blades in packs of up to 800, then shine fluorescent light on the 2 cutting-edge sides. This makes defects visible. Blades that pass this inspection are washed with solvent to remove contaminants. Then dried. The now pristine razor blades go into a vacuum chamber. It draws a chromium-based coating onto the surface, rendering the cutting edges harder and more wear-resistant. Next, spray nozzles apply a non-stick coating which will help the blades glide smoothly over the skin. To adhere the coating permanently to the blade surface, they bake it on for 20 minutes at about 660 degrees Fahrenheit. Quality control technicians test samples again, this time to ensure the blades meet strength specifications. This test machine measures the force required for the blade to cut a thick wad of wet paper to a certain depth. Back in production, workers submerge the razor blades in organic oil for about half an hour. This provides additional protection against corrosion. On the packaging line, The equipment wraps each blade individually in wax paper. The wax coating on the paper helps protect the razor blade against corrosion during storage. Wax paper is also stronger than regular paper, so the blade's razor-sharp edges don't cut through it. The edge of these razor blades are about 10 times thinner than a human hair. A blade typically lasts about 6 shaves, so the average male goes through quite a few, considering that over the course of his lifetime, he'll have spent more than 3,300 hours shaving his face. In the age of disposable razors, the butterfly safety razor still has an edge. This precision metal tool is good for a lifetime of clean shaves. A few twists of the handle, and the butterfly mechanism opens to allow cleaning and replacement of the blade. With it, getting rid of stubble is very little trouble. Invented in the last century, the butterfly safety razor has done its part to prevent injuries. The blade can be replaced without actually touching the sharp edge. The butterfly doors also close around the blade for a safer shave. Also known as the twist-to-open razor, this grooming tool is anything but simple. It's comprised of about 20 parts. Production begins with solid zinc bars. They melt down the bars in a big cauldron. The machine then presses the melted zinc into a mold of 3 razor parts. The zinc instantly cools and solidifies into the shape of the parts. They're linked by more hardened zinc. A worker separates them, revealing a support structure for the blade, a framework for the butterfly flaps, and the outer casing for the blade support part. Breaking them free from one another leaves ragged edges, so a worker grinds them smooth. But there are still a few blemishes to rub off the surface. The parts toss about in a tumbler filled with abrasive synthetic pellets. After about half an hour, the surface irregularities are gone. Next, a computerized drill bores into the center of a spinning aluminum dowel, as a second tool contours the outside. This transforms the dowel into nuts for adjusting the blade. They shape the aluminum handle the same way. Now they apply a more durable chrome finish. This process involves 3 electroplating baths. The first one gives the parts a copper coating. Then it's into the nickel bath. In this case, nickel is a go-between kind of finish. It will allow chrome to stick to the part. After a chemical treatment for a matte finish, they plunge the parts into the chrome bath. A quick rinse in water reveals the result. The parts now have a resilient matte chrome finish. Once all the parts have been fabricated, it's time to assemble the butterfly razor. A worker drives a threaded insert into the outer casing for the blade support. She installs a similar insert in the adjustment nut we saw being fabricated early on. These inserts enable her to screw the 2 parts together. She sets aside the nut and blade support assembly. She slides a spring onto the razor's center rod. This spring pushes up the rod to open the butterfly flaps. She dabs thread lock glue on the threaded section of the butterfly flap support part, and then screws the part to the razor's center rod. Next, she installs the butterfly flaps on the support part. The various subassemblies now need to come together. She begins with the blade support structure and brass stem. She attaches a spring and slides the adjustment nut assembly onto the stem. She inserts a plastic washer into the assembly, allowing her to screw the handle onto the adjustment nut. She now pops the center rod with the butterfly doors into the assembled framework. and adjusts the assembly. She threads a set screw onto the center rod and into the handle. The screw will prevent the user from turning the handle too far and compromising the butterfly mechanism. An end cap attached to the base holds the center rod in place. Finally, she tests the handle and screw rod mechanism that opens the butterfly flaps and confirms that they're fully functional. It's taken about 20 minutes to produce this butterfly safety razor. With regular cleaning between blade changes, it should last for many years. Good thing, because there will always be a growing need for this reusable shaving tool. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.